Vertical and horizontal lines. The equations of vertical and horizontal lines do not require any of the preceding formulas. Although we can use the formulas to prove that the equations are correct, the equation of a vertical line is given as x equals c, where c is a constant. The slope of a vertical line is undefined, and regardless of the y value of any point on the line, the x-coordinate of the point will be c. Suppose that we want to find the equation of a line containing the following points: -3, -5, -3, 1, -3, 3, and -3, 5. First, we will find the slope. M equals 5 minus 3 over -3 minus -3 equals 2 over 0. 0 in the denominator means that the slope is undefined, and therefore we cannot use the point slope formula. However, we can plot the points. Notice that all of the x-coordinates are the same, and we find a vertical line through x equals -3. See figure 3. The equation of a horizontal line is given as y equals c, where c is a constant. The slope of a horizontal line is 0, and for any x value of a point on the line, the y-coordinate will be c. Suppose we want to find the equation of a line that contains the following set of points: -2, -2, 0, -2, 3, -2, and 5, -2. We can use the point slope formula. First, we find the slope using any 2 points on the line. Use any point for x1, y1 in the formula, or use the y-intercept. The graph is a horizontal line through y equals -2. Notice that all of the y-coordinates are the same. See figure 3. Example 13. Finding the equation of a line passing through the given points. Find the equation of the line passing through the given points 1, -3, and 1, 4. The x-coordinate of both points is 1, therefore we have a vertical line x equals 1. Determining whether graphs of lines are parallel or perpendicular. Parallel lines have the same slope and different y-intercepts. Lines that are parallel to each other will never intersect. For example, figure 4 shows the graphs of various lines with the same slope, m equals 2. All of the lines shown in the graph are parallel because they have the same slope and different y-intercepts. Lines that are perpendicular intersect to form a 90-degree angle. The slope of one line is the negative reciprocal of the other, and we can show that two lines are perpendicular if the product of the two slopes is -1. m1 multiplied by m2 equals -1. For example, figure 5 shows the graph of two perpendicular lines, and one line has a slope of 3, the other line has a slope of -1/3. m1 multiplied by m2 equals -1, 3 multiplied by -1/3 equals -1. Example 14. Graphing two equations and determining whether the lines are parallel, perpendicular, or neither. Graph the equations of the given lines and state whether they are parallel, perpendicular, or neither. 3y equals -4x plus 3 and 3x minus 4y equals 8. The first thing we want to do is rewrite the equation so that both equations are in slope-intercept form. First equation, 3y equals -4x plus 3, y equals -4 x plus 1. Second equation, 3x minus 4y equals 8, -4y equals -3x plus 8, y equals 3/4. See the graph of both lines in figure 6. From the graph, we can see that the lines appear perpendicular, but we must compare the slopes. m1 equals -4/3, m2 equals -3/4, m1 times m2 equals -4/3 multiplied by 3/4 equals -1. The slopes are negative reciprocals of each other, confirming that the lines are perpendicular. Writing the equations of lines parallel or perpendicular to a given line. As we have learned, determining whether two lines are parallel or perpendicular is a matter of finding the slopes. To write the equation of a line parallel or perpendicular to another line, we follow the same principles as we do for finding the equation of any line. After finding the slope, use the point slope formula to write the equation of the new line. How to? Given an equation for a line, write the equation of a line parallel or perpendicular to it. 1. Find the slope of the given line. The easiest way to do this is to write the equation in slope-intercept form. 2. Use the slope and the given point with the point-slope formula. And 3. Simplify the line to slope-intercept form and compare the equation to the given line. Example 15, writing the equation of the parallel line to a given line passing through a given point. Write the equation of a line parallel to 5x plus 3y equals 1 and passing through the point 3, 5. Solution. First, we will write the equation in slope-intercept form to find the slope. 5x plus 3y equals 1, 3y equals 5x plus 1, y equals negative 5/3 x plus 1/3. The slope is m equals negative 5/3, and the y-intercept is 1/3. But that really does not enter into our problem, as the only thing we need for the two lines to be parallel is the same slope. The one exception is that if the y-intercepts are the same, then the two lines are the same line. The next step is to use the slope and the given point with the point-slope formula. Y minus 5 equals negative 5/3 multiplied by x minus 3. Y equals negative 5/3 x plus 10. The equation of the line is y equals negative 5/3 x plus 10. See figure 7. Example 16. Finding the equation of a line perpendicular to a given line passing through a given point. Find the equation of the line perpendicular to 5x minus 3y plus 4 equals 0 and passes through the point negative 4, 1. The first step is to write the equation in slope-intercept form. 5x minus 3y plus 4 equals 0. Negative 3y equals negative 5x minus 4. Y equals 5/3 x plus 4 over 3. We see that the slope is m equals 5/3. This means that the slope of the line perpendicular to the given line is the negative reciprocal, or negative 3/5. Next, we use the point-slope formula with this new slope and the given point. Y minus 1 equals negative 3/5 multiplied by x minus negative 4. Y minus 1 equals negative 3/5 x minus 12 over 5. Y equals negative 3/5 x minus 7/5. 2.3, Models and Applications. Josh is hoping to get an A in his college algebra class. He has scores of 75, 82, 95, 91, and 94 on his first 5 tests. Only the final exam remains, and the maximum points that can be earned is 100. Is it possible for Josh to end the course with an A? A simple linear equation will give Josh his answer. Many real-world applications can be modeled by linear equations. For example, a cell phone package may include a monthly service fee plus a charge per minute of talk time. It costs a widget manufacturer a certain amount to produce X widgets per month plus monthly operating charges. A car rental company charges a daily fee plus an amount per mile driven, and these are examples of applications we come across every day that are modeled by linear equations. In this section, we will set up and use linear equations to solve such problems. Setting up a linear equation to solve a real-world application. To set up or model a linear equation to fit a real-world application, we must first determine the known quantities and define the unknown quantity as a variable. Then we begin to interpret the words as mathematical expressions using mathematical symbols. Let us use the car rental example above. In this case, a known cost, such as 10 cents per mile, is multiplied by an unknown quantity, the number of miles driven. Therefore, we can write 0.10x. This expression represents a variable cost because it changes according to the number of miles driven. If a quantity is independent of a variable, we usually just add or subtract it according to the problem. As these amounts do not change, we call them fixed cost. Consider a car rental agency that charges 10 cents per mile plus a daily fee of $50. We can use these quantities to model an equation that can be used to find the daily car rental cost C. C equals 0.10x plus 50. When dealing with real-world applications, there are certain expressions that we can translate directly into math. Table 1 lists some common verbal expressions and their equivalent mathematical expressions. How to. Given a real-world problem, model a linear equation to fit it. 1. Identify known quantities. 2. Assign a variable to represent the unknown quantity. 3. If there is more than one unknown quantity, Find a way to write the second unknown in terms of the first. 4. Write an equation interpreting the words as mathematical operations. 5. Solve the equation and be sure the solution can be explained in words including the units of measure. Example 1. Modeling a linear equation to solve an unknown number problem. Find a linear equation to solve for the following unknown quantities. One number exceeds another number by 17 and their sum is 31. Find the two numbers. Solution. Let x equal the first number, then as the second number exceeds the first by 17, we can write the second number as x plus 17. The sum of the two numbers is 31. We usually interpret the word as an equal sign. X plus 17 equals 31, and 2x plus 17 equals 31. 2x equals 14, x equals 7, x plus 17 equals 7 plus 17 equals 24. The two numbers are 7 and 24. Example 2. Setting up a linear equation to solve a real-world application. There are two cell phone companies that offer different packages. Company A charges a monthly service fee of $34 plus 5 cents per minute talk time. Company B charges a monthly service fee of $40 plus 4 cents per minute talk time. A. Write a linear equation that models the packages offered by both companies. The model for Company A can be written as A equals 0.05x plus 34. This includes the variable cost of 0.05x plus the monthly service charge of $34. Company B's package charges a higher monthly fee of $40 but a lower variable cost of 0.04x. Company B's model can be written as B equals 0.04x plus $40. B. If the average number of minutes used each month is 1,160, which company offers the better plan? If the average number of minutes used each month is 1,160, we have the following. Company A equals 0.05 multiplied by 1,160 plus 34 equals 92. Company B, 0.04 multiplied by 1,160 plus 40 equals 86.4. So Company B offers the lower monthly cost of $86.40 as compared with the $92 monthly cost offered by Company A when the average number of minutes used each month is 1,160. C. If the average number of minutes used each month is 420, which company offers the better plan? If the average number of minutes used each month is 420, we have the following. Company A equals 0.05 multiplied by 420 plus 34 equals 55. Company B, 0.04 multiplied by 420 plus 40 equals 56.8. If the average number of minutes used each month is 420, then Company A offers a lower monthly cost of $55 compared to Company B's monthly cost of $56.80. D. How many minutes of talk time would yield equal monthly statements from both companies? To answer the question of how many talk time minutes would yield the same bill from both companies, we should think about the problem in terms of XY coordinates. At what point are both the x value and the y value equal? We can find this point by setting the equations equal to each other and solving for x. 0.05x plus 34 equals 0.04x plus 40. 0.01x equals 6, x equals 600. Check the x value in each equation. Therefore, a monthly average of 600 talk time minutes renders the plans equal. See Figure 2. Using a formula to solve a real-world application. Many applications are solved using known formulas. The problem is stated. A formula is identified. The known quantities are substituted in the formula. The equation is solved for the unknown, and the problem's question is answered. Typically, these problems involve two equations representing two trips, two investments, two areas, and so on. Examples of formulas include the area of a rectangular region, A equals LW, the perimeter of a rectangle, P equals 2L plus 2W, and the volume of a rectangular solid, V equals LWH. When there are two unknowns, we find a way to write one in terms of the other because we can solve for only one variable at a time. Example 3, solving an application using a formula. It takes Andrew 30 minutes to drive to work in the morning. He drives home using the same route, but it takes 10 minutes longer, and he averages 10 miles per hour, less than in the morning. How far does Andrew drive to work? Solution. This is a distance problem, so we can use the formula D equals R times T, where distance equals rate multiplied by time. Note that when rate is given in miles per hour, time must be expressed in hours. Consistent units of measurements are key to obtaining a correct solution. First, we identify the known and unknown quantities. Andrew's morning drive to work takes 30 minutes, or half multiplied by h, at the rate r. His drive home takes 40 minutes, or 2/3 an hour, and his speed averages 10 miles per hour, less than the morning drive. Both trips cover distance d. A table such as Table 2 is often helpful for keeping track of information in these types of problems. Analysis. Note that we could have cleared the fractions in the equation by multiplying both sides of the equation by the LCD to solve for r. Example 4. Solving a perimeter problem. The perimeter of a rectangular outdoor patio is 54 feet, the length of 3 feet greater than the width. What are the dimensions of the patio? Solution. The perimeter formula is standard. P equals 2L plus 2W. We have two unknown quantities, length and width, and however we can write the length in terms of width as L equals W plus 3. Substitute the perimeter value and the expression for length into the formula. It is often helpful to make a sketch and label the sides as in figure 3. Now we can solve for the width and then calculate the length. The dimensions are L equals 15 feet and W equals 12 feet. Solving an area problem. Example 5. The perimeter of a tablet of graph paper is 48 inches squared. The length is 6 inches more than the width. Find the area of the graph paper. The standard formula for area is A equals length times width. However, we will solve the problem using the perimeter formula. The reason we use the perimeter formula is because we know enough information about the perimeter that the formula will allow us to solve for one of the unknown. As both perimeter and area use length and width as dimensions, they are often used together to solve a problem such as this one. We know that the length is 6 inches more than the width, so we can write length as L equals W plus 6. Substitute the value of the perimeter and the expression for length into the perimeter formula and find the length. P equals 2L plus 2W, 15 equals L, 9 equals W. Now we find the area given the dimension of L equals 15 inches and W equals 9 inches. A equals L times W, A equals 15 times 9 equals 135 inches squared. Example 6, solving a volume problem. Find the dimensions of a shipping box given the length is twice the width, the height is 8 inches, and the volume is 1,600 inches cubed. Solution. The formula for the volume of a box is given as B equals L times W times H, the product of length, width, and height, and we are given that L equals 2W and H equals 8. The volume is 1,600 cubic inches. V equals L times W times H. 1,600 equals 2W times W8. 1,600 equals 16W squared. 100 equals W squared. 10 equals W. The dimensions are L equals 20 inches, W equals 10 inches, and H equals 8 inches. Analysis. Note that the square root of W squared would result in a positive and negative value. However, because we are describing width, we can use only the positive result. Access this online resource for additional instruction and practice with models and applications of linear equations. Problem solving using linear equations, OpenStacksCollege.org, problem solving using linear equations, finding the dimensions and area giving the perimeter, find the distance between the cities using the distance equals rate times formula, and the linear equation application, write a cost equation, OpenStacksCollege.org.